This morning I was spending time on Discord, and a poster there was asking about the actor pattern in Rust, and quoted this blog post here called "Actors with Tokyo." And I looked at this, and there was really the question was using actors to avoid locking mechanisms, where there's sort of some contesting of data structures, and really looking at the idea of using the lock of the actor pattern. Is that the right way to do it? And there's of course answers about it being, well, it really depends on what you're doing. There's latency, there's concurrence. There are lots of reasons why you want to do it or not. Um, this is a fine implementation of this, but I really started to like looking at this. There were things that I didn't like about how this was implemented. In particular, um, using using structs here, using data structures, using this kind of this smells very much like C sharp, C++, Java. Everything must be in a class sort of mentality. And lately I've been getting away from that, in particular when thinking about traits, and thinking not about traits as not being interfaces for future structs, but being a description of a behavior that needs to be done. So let me get into it. Actually, so I I didn't see who wrote this blog, and came across the video, and I clicked over in the video. I'm like, oh, this is Alice. So Alice is brilliant. She has a lot of great stuff, great videos. In particular, there's one about atomics that's posted out here. Really, really great stuff. So in a way, I'm almost honored to try to make Alice's work better or different. And I want you to look at this as a not an attack on actor, not an attack on Alice's implementation, but to look at how we can make this implementation do the same thing without all of this extra noise that's in place here. In particular, the noise that I'm looking at is we have struct my actor message, we have an implementation of my actor, we have a my actor handle, and there's a lot of stuff that is tying the developer very specifically to using things where they know about what the internals is being done. And I just want to offer a better, in my opinion, solution to this to achieve the same thing that is cleaner with a lot of, well, I don't know what the word is. Let's just go into it and see where we end up. So I've already included in this anyhow and Tokyo, and I want to sort of just show how the two different implementations are being used, and it's really going to be the same regardless. So in we're going to create an actor, and let's create a handle of this. I'm checking my code over here so we can create two new IDs, and let's print them out. And this should run just fine. This is using Alice's version of the actor handle and giving a very clean implementation for the developer. So I'm going to write my own version of this, and it's going to look very similar. So let's give us some room here, and we're going to call this mine. And I just, for one, you know, let me go into mine, and we're going to start from this, because I want you to sort of get an appreciation for my thought process going into this. So I want to have a pub trait, and we're going to have this a generator, and this is going to be an async fn that's get unique ID, and we're also going to return this as a result because it's possible that this could fail. So this is what we want it to. This is what we want our interface to look like. It's very similar or almost identical to the interface that is created here, except we're not using it through a trait system. And I'm using it through a trait system because it'll just make a lot of sense once we put this into practice. Now, Rust is going to complain about the use of async in traits because it's kind of a new thing. So let's just turn off that warning so that it's not going to complain at us about using async in a trait. So what is this going to look like? So I like to use traits to say, I want to teach the compiler how to have a data structure behave like whatever it is that we're defining in a trait. That is my new thing. So let me just say that traits are ways of teaching the compiler to have a type behave in a certain way. That's a great way to put it. So what do I mean by this? Well, let's say we're going to implement generator for U32. And that seems weird, but this is the implementation for this. Getting a unique or getting an ID, it's not going to be unique, but it is going to be true. Like this is going to sort of work. So it just as a way of doing this, we can say, well, let's we're going to have this sort of factory method. I don't get hung up on the idea of factory methods and it returning generic traits. Create a const ID generator. It'll if you get rid of what you used to think of factories, this is just fine. So this is going to return an impl generator, and we're just going to 42. That's a great number. And this all works so far. This should compile, right? No issue. So let's use this in main. So let generator equal mine create const ID, and we're going to generate two IDs. Let's generate two IDs, and sorry. There we go. Let ID 2. Come on, Copilot. There we go. Println. Fine. Now it is let's bring some stuff in here. We're gonna have to bring in two things. One is going to be that we have to also bring in the generator trait. But now, you know, we have a const ID generator, and it's always going to be returning 42 like this. Now, also, we need to not get hung up on like, well, we are now using traits as a way to replace things. We're not doing that per se. But we're using traits right now, and like, I am not implementing Alice's version of this yet. I'm getting there, showing you. I'm really kind of more focused on the trait system. But once we then implement Alice's in a system that is using this understanding of traits as teaching data types how to behave in a certain way, then it's just going to make a lot of sense. So there's actually some implementing generator for an option U32 actually makes a lot of sense. So we want, in this case, to, well, we can probably do this in one line. We want to do self take. Okay, no more IDs. This needs to be mutable now. Okay, so we kind of discovered a thing that we need to have for this, because the generator might obviously need to mutate itself, and we're going to have to now make these mutable, but that's okay. But this new implementation for option U32 does make sense, because the first ID that it returns is unique, and because it's already consumed that, we don't have any more to give. So, we now have a good sort of pattern here that is working for us. And I'm not doing this to, because these are implementations that I want to have, but to show that there's this like aha moment that is starting to come into play, is starting to happen. We can actually just do this. A generator is going to be sum of 42. That is a generator, because there is a unique ID for that. So we can run this, and I'm not going to question mark on this. Let's get the debug version of both of those. So we can see that not for const, but this is an optional. The first one we got was an OK42. The second one said, oh, we've exhausted that. Now let's go even a little bit further down this rabbit hole, because I'm having fun. Impl I generator for I, where I is an iterator of those. Yeah. Now this, we do have, sort of some issues with these. You can see where I'm going, and I actually knew we were going to kind of run into this because of this sort of issue. And I want to be able to get around this, but let's actually not do a complete blanket implementation of this. We'll put that aside for the moment. Let's get into the actual implementation of what it is that it was. Oh, actually, here's another great one. I do want to go one more. So we're implement generator for arc mutex of U32. And yeah, this is an obvious way of doing it. Which, again, like we can create this. Create locked ID generator, and we're going to start at 0. And, this is going to be a similar implementation. Use case locked. So, we have these multiple cases. We don't have to do this. There we go. There we go. So, we have a const one that's returning us not really what we want, but it's fine. Could we do this? Oh, the const one is not right. Because get unique ID, we can actually, we could do this. Yeah, star self plus. Let's actually do the right thing. Star self equals self. We don't want wrapping add. We want checked add, because we might hit the end of it. Okay, or else no more IDs. okay, star self. There. So, you know, this is one that is, it's not going to be thread safe, but we are able to get incrementing IDs. In this case, for creating a locked ID generator, we can say that this is send and sync, because we can send this generator across threads. So, you know, in this case, we've sort of implemented the non-actor version of it by right here. You know, this is the locked version of an ID generator that is thread safe, sendable and sync through threads, and is a non-actor version. Very simple, short and sweet, and really kind of cool that we also have a non-locking version of it that is working just for plain U32s without any structs in here at all. Okay, let's get into kind of what I was teasing at the beginning of the video. We're going to do this in the actor method. So let's look at what we have with Alice's. So in Alice's one, we have a message that we're sending. There's only one message, which is actually like it's demonstrating the actor pattern where you would have other messages, but in this case, the enum is unnecessary, so we're going to get rid of it. And we're actually not going to store this in a struct. We're going to keep this on the stack. And we're going to let Rust in the async mechanism be able to generate our structs for us. So here's what it's going to look like. I've already done this on the side, so I'm going to pull in these types here. We're just going to copy and paste this in here. So the request is going to be a one-shot sender. And here, let me pull up Alice's on the side here. So this is, you know, the whole request. It's a one-shot sender, and I am not wrapping it in enum. I'm just going to have the request be the sender itself. And a request sender is going to be an MPSC sender of the request, and the receiver is going to be this. This is just a nice way to write types so that when we write our generators against this, it's going to work fine. So there's two things that we have to do. One is we need the sort of async pub. Is it pub async or async pub? I think it's pub async. Actually, well, we can just create an async. We don't have to make a pub here. An async event. So the actor, the routine that's going to be running is going to have this, and it's already completing because it's already seen me do this before. This is our actor work. It's really combining this code here, the handle message, and this loop here, kind of all in one. So, you know, what it's doing here is, you know, we're keeping the next ID on our async stack or async state. We're letting the compiler turn that into some sort of data structure. This is the entire actor. The state is held here on the stack. We're incrementing it, and when we get a request and we return that as a response, the request itself is a sender. So this is very, very trivial, very straightforward. So now we have to teach Rust how to behave like a generator for a request sender. So we're going to implement generator for request sender. Oh, This is nice. And again, Copilot completed this because I've done this already. This is it. We create a channel to send our request on. We send that one shot to the channel that we are. We are a request sender, so we send it to ourself because we're a sender, and then we wait for the return. And the map error, I personally prefer this syntax. This is just to turn that into an anyhow error correctly, and we're still compiling. It's complaining about we're not using this, but like this is our actor pattern. Here's our actor. Here is what we're doing it, and we're doing this directly on the data types themselves. So when I'm going to create that factory function, create actor ID generator. Do not want that. Kind of want. That's weird. Let me look at my. I'm going to paste what I have in because that's not really what I want. So this is what I am doing, and this is really cool because I am creating something that is going to return a tuple. The first tuple is my actor, something that needs to be spawned or somehow awaited on in order to do the work. I am not spawning it inside of here. I am returning the async future to the caller. So let's write this down. And what I'm doing here is I'm really I'm allowing the caller to manage the lifetime of the ID generator, because that's not really my responsibility here. So we're still building. Let's implement this. So main, what does this look like here? Mute actor. Really, it's going to be actor, comma mute generator is going to be mine. Create actor ID generator. Good. And we are going to do Tokyo spawn our actor here. And there we go, println. And I believe this should work fine. We're doing the same thing, except we are spawning this here. And there's any number of ways that we could actually keep that actor active and alive and doing the work that it needs to do. So this got a little bit longer. I got really carried away with a lot of the trait stuff, but it's honestly the trait system and the use of that in this new way, not this new way, but the way that I've been trying to teach it in is the important part here. So let's put these a little bit side by side. We can look at code count. I hate doing that, but this actor pattern here in code count is say 63 bytes, and mine here really consists of this, which is, I don't know, let's say 7. And sorry, that's the creator. Anyway, it is compact in the sense that we are using functions themselves to hold the state instead of creating new structs that somehow have to be mentally managed. The generator is generic, not so that we can replace it, but because it makes sense even in just this one case where we're not using the generator or using the trait to have multiple implementations. We are teaching request sender, which is a MPSC sender. We are teaching that how to behave like a generator, and the generator is our contract to the developer saying that we can get a unique ID that might fail and it's going to be asynchronous. That's all we're saying. And each one of these implementations does this, even if we're only doing one. And we're teaching basic types, or, well, even complex types, how to behave like this without having extra wrappers and other things like this. And, it's not a lazy way of doing this or a way to cheat or shortcut the system. It is sort of how it needs to be done in the first place. So I'm getting, I'm circling around this with a lot of these long videos that keep sort of demonstrating the point over and over again. And it allows much cleaner implementations that really make sense without a lot of additional actor, senders, handlers, all that stuff. It just works. So I hope I'm making sense on the other side of this video. It's hard to communicate this out to the ether without a human being on the other side of this giving me feedback, but I'm doing my best, and hopefully you're learning something from what I'm putting out here.